Hello class, good day. Before we start with our next topic about the inductive and deductive reasoning, let us just have a recap on what we have discussed last time about the fundamentals of logic. So what we're going to do here is we're just going to recall all of the logical symbols as well as with the logical connective. Also, we're going to recall the truth table for different logical operators. So the first one, we have the conjunction. For conjunction, we use this symbol. And our logical connective here is the word and. Okay. So for the truth table for conjunction, so like what I've said, this is just like multiplication of binary numbers. So if we have two premises or two propositions P and Q, this will be our P conjunction Q. So let us just draw table here. So we have 1, 1, 1, 0, 0, 1, and 0, 0. So just like multiplication, we're just going to multiply the values of P with the values of Q. That is 1 times 1 is equal to 1. Or if there is a presence of false in this statement or 0, it means that our value is always 0. Because any number multiplied by 0 will always result to 0. So then the next numbers will be 0, 0, 0. Okay, this will be our truth table for conjunction. Okay, the next operation that we're going to deal with is disjunction. So, palitan lang natin yung values nito, no? Mamaya for our truth table. So, for disjunction naman, we use this as our symbol. And inclusive yung word na or for our logical connective. So, that is P or Q if we're going to form a statement using disjunction. For our truth table naman, let us just refer to this one as P disjunction Q. So this is a little bit different because instead of multiplying, it is just adding these two together. Pero let us always take note that 1 plus 1 is equal to 1 when it comes to disjunction. Or if there is a presence of truth in every statement, it means that the value is true. We can only attain the value of false only if both of the statements are false. So it means that here we will obtain 1, 1, 1 because there is a presence of truth in these statements. But if there is no presence of truth, so we will have a value of 0. Okay, now this will be our truth table for disjunction. Later on, as we discuss the bitwise operators, as we recall bitwise operators, we're going to redefine disjunction, conjunction, and exclusive or. Most likely kasi ito yung mga ginagamit natin, no, in our bitwise operations. Okay, so just the same thing, I'm just going to delete these values and then let's try to discuss the next. That is all about exclusive or. Now, when we say exclusive or, this is also a disjunction. So, but the difference is it has been made exclusive. Okay, so we can only attain the value of 1 if only one of the statement is true, otherwise it is false. So let's proceed to our truth table. What will be our symbol pala for exclusive or? This will be our symbol for exclusive or. Okay, so if we're going to refer to our truth table, if we have there both of the values equal to 1 or true, so it means it is equal to 0 because what we require is kailangan daw meron lang tayong isang true value for both of the variables. Okay, at least 1 or at most 1 true value for P and Q or for our propositions. So if they possess both false, syempre false pa rin yung kanyang value. Okay. Next is about negation. So for this truth table, so kuhanin ko lang yung negation ng isang proposition because if we're talking about negation, it is particular to a single proposition. Let's say we're going to negate P. So this will be our symbol for negation. So it can either be this symbol or this symbol. Okay, inclusive yung word na not if we're going to use this in our statements. Okay, let's try to get the negation of P. If it is not 1, then it is 0. So if it is not 1 also, it is 0. So we have here 1, 1. So very basic yung ating negation. Ano? Next one is implication. Okay. This is just to correct our conception in our previous discussion because the PowerPoint that I have used was wrong. No? But let us just follow this convention. When it comes to implication, this will be our symbol. Okay, then in order for us to create a statements or to combine proposition using implication, we have this pattern if P, okay, then Q. Okay, now let's try to look at the truth table. So if we have here P, Q as our propositions, we have here P implied Q. So it is being said there that we can only have a false value only if the conclusion is false. Otherwise, it is true. Okay, so if the conclusion is false, so sir, ibig sabihin, dito lang tayo magkakaroon ng false na value tsaka dito. So the last part, if both of the statements are false, so wala namang sinabi doon na kapag both of the statement ay false, ay magiging false yung value natin. It is only when our conclusion is false. So let us just correct our perception of the values for our truth table in the implication. So this will be 1, 1, and 1. This will be our truth table for implication. And lastly, we have what we call biconditional. For biconditional statements, so this is just like implication, but the difference is yung symbol nila, no? Kasi gagamit tayo ng two arrows. Okay. And inclusive yung word na if and only if. Okay. This is if and only if. This is also called as good definition. Aside from good definition, this is also called as by implication. Okay, this is by implication. So what is in the biconditional? It is being said there that if we have two values or we have to satisfy both values to make the statement true. This is unlike the exclusive or, wherein we just need a single value, we just need a single true value for a variable. Biconditional is just the negation of our values or our truth table for exclusive or. So because there, it only requires one true value, but for the biconditional, it requires both value to be the same to make the statement true. For example, we have there 1, 1. So we can attain a value of true here, and both of them are false. That is also 0. If they have different values, it means it is 0. Because we don't satisfy both of the conditions. But if we satisfy both of the conditions, it will give us a true value. Okay, this is the recall of our topic in the last discussion. But anyway, let me just add something about the implication. When we say implication, there are also different types of implication wherein we can interchange the position of our hypothesis and our conclusion. So let me just delete this truth table first and let us recall something about the implication. So when we say implication, meron daw siyang tatlo. The first one is what we call converse. We also have the inverse. And lastly, we have what we call contrapositive. So what is contrapositive? Okay, so what is in the converse? When we say converse, we just interchange the position of the hypothesis and the conclusion. So instead of P implied Q, we're going to make it implied P. For converse naman, instead of using the original implication P implied Q, we're going to negate the implication P and Q. So this is the negation of P and Q. Or if we're going to distribute the negation sign to our symbols, it will give us negation P implied negation Q. And lastly, for contrapositive, this is just the inverse of our converse. So if we're going to get the inverse of our converse, it will give us negation Q implied negation P. This will be our recap of the topic fundamentals of logic. Okay. And to add more from it, so magkaroon na rin tayo ng iba pang examples for bitwise operations. So we have three different operations there. So pwede nating mag-apply ng bitwise AND, bitwise or bitwise XOR. So let me just delete the screen again. Okay, so bitwise operation. So for the bitwise operations again, we have what we call bitwise OR and XOR. Okay, kanina naman na-recall na natin yung mga truth table na gagamitin natin for OR and XOR. We're going to implement that in this bitwise operation. Okay, so for example, we have two different values of bits. That is 1 0 1 1 1 0 0 1 and 1 1 1 0, and the other one will be 1 0 0 0 1 0 1 1 and 0 1 1 0. Okay, let us apply different operations. Now first, let us have a bitwise OR. For OR, okay, always take note that we have to be mindful of the values of 1, because if there is a presence of 1, it means the value of our particular bit will be equal to 1 also. So let's look here. So that is 1 0 0 0. It will be equal to 0. So this one is 1 because there is a presence of 1. Then we have here 1 1 0 1. Okay. So next thing is now this will be our value for OR. That's very basic. Now we just have to be mindful of the values of 1. For AND, bitwise AND demand, we have to be mindful of the values of 0, because if there is a presence of 0, it means that our value will also be 0 for that particular bit. So it will be equal to 0. This one is 1 1 0 1 0 0 1 and 0 0 0 1. So this will be our answer for bitwise. And lastly, for XOR naman, we have to look at the values. If both of the values are the same, then it means the value will be equal to 0. So this one are the same. It means it is equal to 0 0 0 1. We have here 0 again, 1 0 0 and 1 1 0 0. Okay, this will be the value for bitwise XOR. And lastly, for in addition to this bitwise operation, we can also formulate our own truth table. So how can we formulate our truth table? So let me just give you another example of how can we formulate our truth table. Let's say we have P, this conjunction negation Q, and we're going to imply it with let's say we have Q, this junction of P. Okay, let's first and foremost, let's try to draw a truth table. We have here P, Q. Okay, aside from the values of PQ, we have different tables. So we have 1 1 1 0 0 1 and 0 0. Then let's try to get the negation of Q first. So unti-untiin natin per table, no? Let's try to find the negation of Q. These are the values that are not the values of Q, okay, in that region. So we have 1, it is equal to 0. So 0, if it is not equal to 0, then it is equal to 1. Okay, this is 0, this is 1. So as we are done with negation of Q, so we can now find its conjunction with the P. So ito naman yung titingnan natin, no? Let me just use another color of pens para hindi tayo masyadong malito. So we're going to be, or to apply the conjunction in this part. So we now have P conjunction negation of Q. Okay, so let's try to get it. It is being said there that we can only have a true value if both of the statements are true. Otherwise, it is false. So dito lang tayo parehas because the values are 1 and 1. Otherwise, if there is a presence of 0, our statement will be false. So this is 0, 0, 0. Okay, next thing is let's find the disjunction of Q and P. So, madali lang. Ito lang dalawa na yan. Ha? Ito lang dalawa. Okay, if we're going to find its disjunction, if we have a presence of 1, it means the value is also equal to 1. So, this is just 1, 1, 1, and 0. Okay, this is Q, disjunction of P. Now, lastly, so perform na natin yung indicated operation. Ito, lastly, implication na lang. So let this be our new P and this one will be Q. No, gawin ko na lang. No? This one will be our P prime and this is our Q prime para medyo madali at medyo mabilis. So we have here implication with our Q prime. Then now, let's try to perform the indicated operations. Implication, it means na kapag daw false yung ating values on the other end, it will give us a false value. So if yung conclusion daw natin ay false, it will give us a false value. So let us now look at this table. So yung false value lang natin is on the last part, which is 0, 0. But according to our truth table in implication, kapag 0, 0 siya, 1 pa rin yung values natin. Okay, let us always refer to our truth table, but again, it doesn't require you to memorize the truth table. I want you to be familiar of it and be familiar of the concept. So we have here 1, 1, and 1. So this will now be the result of our truth table for this particular problem. Okay, we can also do this in multiple variables. So pero kailangan natin mag-add ng values na sige, try natin mag-add ng values. Let me just create another example. Let's say we have P implied R conjunction with P implication with negation of Q. Okay, so let's say this will be our values. Now let's we have here 3 variables. So dahil 3 variables, medyo dadami din yung ating output for our truth table. So we now have here P, Q, and R. So meron ba tayong negation? Meron na yung negation of Q. But we can now solve for the first one. Sige, mamaya na to para medyo magkatabi na sila mamaya. Okay, let's solve for the negation of Q first. Okay, ano ba yung mga values na ilalagay namin dito, sir? This is just like binary numbers. Okay, let's start with 1, 1, 1. Next is 1, 1, 0. So 1, 0, 1. 1, 1, 0, 0. Next is 0, 1, 1. 0, 1, 0. 0, 0, 1. And lastly, we have 0, 0, 0. So next thing is we're going to get the negation of Q. We have there 0, 0, 1, 1, 0, 0, and lastly we have 1, 1. Then let's try to get the implication of P and R. We have P implied R. Okay, tingnan lang natin yung may false na conclusion. Ito lang, no? This part, and wala na. Okay, so dalawa lang pala yung ating false na values here between P and R. So, and otherwise it is false. So dito sa otherwise that is true. No, dalawa lang. This is this one, and otherwise. And the other values will be true. Okay, so next is P implied negation of Q. So we have P implied negation of Q. Okay, we're going to look at these values. Let me just use a different color of pen. So dito na tayo at dito sa part na to. Okay, compare natin sila. Tingnan natin yung implication. So magkakaroon lang daw tayo ng false value only if our conclusion is false. So this one, false yung value natin. False. So the other one, so wala na, no? So dalawa lang yung false value natin din. Okay, so dalawa yung false. We have there 0, 0, and the rest will be equal to 1. So as we are done here, let us take note that we are going to apply conjunction pa. It is just like multiplication. So multiply lang natin yung dalawa. If there is a presence of 0, then it means the answer is 0. So let me just place here, let this be our P prime and Q prime. So P prime and Q prime. This is also, so let me not be mistaken, no? This is what we're going to write in the last column. So para pinadali ko lang, ito lang yung ginawa ko. No? If there is a presence of 0, then the answer will be 0. So 0, 0, 1, 0, 1, 1, 1, 1. Okay, this will be our truth table for this particular problem. Okay, so next topic that we're going to discuss is about inductive and deductive reasoning. Okay, now let's try to discuss inductive reasoning. So without further ado, allow me to introduce you the objectives of the lesson. At the end of the lesson, you should be able to perform the following tasks. Number 1, define inductive reasoning, verify the validity of conjecture, and find a counterexample to disprove a conjecture. Inductive reasoning, it means it is a type of reasoning that uses a specific example to reach a general conclusion. So mostly it is just done based on observations of these examples. The conclusions formed by using inductive reasoning is called conjecture. Okay, note that a conjecture is an idea that may or may not be correct. Because just like what I've said earlier, most likely these inductive reasoning are just done using observations of the previous events. So most likely, yung mga problems natin involving sequences are a form of inductive reasoning, or is an example of inductive reasoning. So determine the next two numbers from the sequence below. So it doesn't always mean, let us just have an idea that it doesn't always mean that our answers are correct. It is just that we have provided that answer based on our observations of the behavior of our sequences. So for number 1, we have there 10, 15, 0, 5, negative 10, and negative 50. So maybe, it is maybe that the next answer will be 0 and the next one will be negative 5. So why? Because this is just a pattern, that is 10, 15, 0, 5. We have negative 10, negative 15. So maybe the next one will not be negative 0, because there is no such thing as negative 0, but 0 alone. And then the next will be negative 5. This was just my observation, because if you're going to find the differences between the values of the present term and the previous term, you will not arrive with a correct answer. Kasi Kung titingnan naman natin yung differences, we have here 5. So, nag-plus tayo ng 5 minus 15 plus 5 minus 15, okay, minus 5. So, iba naman siya. So, maybe it is a little bit different. No, that's why my guess was 10, 15, 0, 5, negative 10, negative 15, then the next one will be 0 and negative 5. Okay, to make this correct. Okay, this is just based on observations. The second one, we have 8, 16, 32, 64, 128, and 256. Based on my observation, these numbers are just multiplied to 2 to get the next term. So maybe the next term will be equal to 256 times 2, which is 512, and the next one will be equal to 1024. For number 3, we have 26, 12, 25, 13, 24, 10. So let's try to find the difference, okay, between the two. So it is maybe that it is minus 14, then plus 13, minus 12, plus 11, minus 10. So it is maybe that the next one will be plus 9. Then the next one will be minus 8. So plus 9, that is 14 plus 9, it will give us 23. Then minus 8, it will give us 15. Okay, so maybe these are the values based on observation. Okay, and number 4, we have 50, 25. So we have 30, 15, then 20, 10. And lastly, we have ano kaya yung values dito? So as you can see, these number are just divided to 2, then we are going to add a plus 5 to get the next term. So we have 30 divided by 2 again, it is equal to 15. Then 15 plus 5, it is 20 divided by 2 is 10. So next, maybe it is equal to 10 plus 5, which is equal to 15, divided by 2, it is equal to 7.5. So these are the values for number 4. And for number 5, we have 16, 18, 20, 22, 24, 26. So this one is very basic though, because we have a common difference of 2. Okay, so it is maybe that the next term will be equal to 28 and then 30. Okay, these are the examples of inductive reasoning. And again, these are just based on observations. Okay, example also, use the data in the table and answer the following questions. So this will be our data: earthquake, magnitude, and the maximum height in meters. Siyempre, the higher the magnitude of the earthquake, the higher also the tsunami that it can produce. So now let's proceed to the problem. If an earthquake magnitude is 8.5, how high in meters can tsunami be? Okay, balikan natin yung ating table. So we have their earthquake magnitude up to 8.1 alone. And the value that we will be looking for will be 8.5. So it means we have to approximate values. But how can we approximate the values? We can also use, or we can use observations here. See, we have a linear relationship between the earthquake magnitude and the tsunami, the height of the tsunami. Okay, and we can predict the height of the tsunami based on the values that we're going to set for the values of the magnitude. Okay, these are directly proportional with each other. As the earthquake magnitude increases, the tsunami height also increases. Okay, we can create another table for us to solve the problem. So let's add 8.2 here, 8.3, 8.4 up to 8.5. So again, like what I've said earlier, based on our observation, if the magnitude is increased by zero point 0.1, then the tsunami height also increases by 4. So if the last one was 25, then plus 4, it will give us 29. Plus 4, it will give us 33, 37, and then lastly, we have 41. So if the magnitude is increased up to 8.5, then the maximum height of the tsunami will be increased up to 41 meters. Okay, for the next question, balikan lang natin, no? Can a tsunami occur when the earthquake magnitude is less than 7? Explain your answer. So this was our table, and we're going to go backwards from 7.5 if the magnitude is 7. So let's say, for example, we have 7.4 here. So it means that this tsunami height will be decreased by 4. So it means for 7.4, it will give us 1. For 7.3, so if 1 will be decreased by 4 meters, it will give us negative 3 meters. And when it comes to tsunami, this is about the rise of the water above the sea level. It means that we cannot have a negative value. No, hindi pwedeng negative yung tsunami natin. Hindi pwedeng pailalim yung tsunami. So the answer will be no. So there is no tsunami if the magnitude is just or is less than 7. So now, let's talk about counterexample. It is a method that is proving a conjecture. So for example, give a counterexample on the following equation. So we have there x over x is equal to 1 and x squared plus 4 is equal to x plus 2. Okay. Here, we can say that this one is really true. No, because all of the numbers divided by the number is also equal to 1. But what if that number is referring to 0? So is 0 over 0 equal to 1? So this is not equal to 1 because this number is an indeterminate number. Okay, so we have to take note that if we're going to divide x by itself, x must not be equal to 0 because it will give us indeterminate number. It is our counter example for this particular conjecture. Okay, so the next one, x squared plus 4 is equal to x. Oh, sorry, square root of x squared plus 4 is equal to x plus 2. Okay, this is not a special product. So, kung iniisip mo na, or this is not as a perfect square, or it doesn't have a perfect square. So, kung iniisip natin na perfect yung square niya, so hindi. Ano? Okay? What we're going to do here is to substitute a value for x. So, subukan natin mag-substitute ng value for x. If x is equal to 2, then we have here 2 squared plus 4 is equal to 2 plus 2. So, 8, square root of 8, sorry, square root of 8 is equal to 4, and they are not equal. So, maybe this one will be our counter example for our example number 2. Okay, and which of the following statement is true or false? Provide a counter example if the statements are false. Okay, the product of two even number is also even. So let's say that the even number is 6 and 8. So their product is also an even number which is also equal to 40. Okay, so how about, let's say that 4 and 8. And will give us 32. This is also an even number. Okay, so we can say that the first example is true. Okay, how about the second example? The sum of two consecutive odd number is even. Let's say that the number is 5, 3 and 5. So their sum is equal to 8. Let's say that 5 and 7. So their sum is also equal to 12, which is also an even number. Okay, how about 7 and 9? So this is also an even number. Okay, we can see that the second example is true. How about the third one? The product of an odd number and an even number is odd. Let's say that an odd number is 5, and the even number is 6. Their product is equal to an odd number. So dito pa lang, no, mali na agad because 30 is an even number. So this one will be our counterexample for number 3, which proves that the statement is false. So the number divisible by 9 is also divisible by 6. So let's say that 27 is divisible by 9. Is 27 divisible by 6? So the answer is no. Because 27 divided by 9 is equal to 3, and 27 divided by 6, we can divide this, but there is a certain remainder. So that is 4 remainder 3. So number 5, a number divisible by 3 is also divisible by 2. Okay. If we have our example 6, so divisible ba rin siya by 2? How about 9? 9 is divisible by 3, but 9 is not divisible by 2. So this one will be our counterexample for example number 5. Okay, this is inductive reasoning. Okay, as we are done with our discussion of inductive reasoning, now let us try to discuss deductive reasoning. So what is deductive reasoning? By definition, it is a type of reasoning that uses general procedures and principles to reach a conclusion. Okay, it is the process of reaching a general conclusions by applying general assumptions, procedures, or principles. So what is the difference between deductive and inductive reasoning? When we say inductive reasoning, it is just about observation. When it comes to deductive reasoning, we follow a certain procedure. Just like this example. So use deductive reasoning to make a conjecture. Consider the following procedure. Pick a number, multiply the number by 10, add 8 to the product, and divide the sum by 2 and subtract 4 from the quotient. Okay, this is an example of a deductive reasoning since we follow a certain procedure. These are some of the generalized principles in deductive reasoning. The first one we have PEMDAS, or what we refer to as GEMDAS in our previous discussions. Okay, so when we say PEMDAS or GEMDAS, we follow a certain procedure, starting from the groupings, followed by the exponent, followed by the hierarchy of operations that we use in mathematics. Those are the multiplication, division, addition, and subtraction. We also have different properties like zero property of real numbers, addition property of equality, multiplication property of equality, and other example, if a line is parallel to any line on the plane, then it is parallel on the plane. Okay, again, these are some of the generalized principles in deductive reasoning. We can have lots of other examples out there. Okay, and some of it are the properties of equality. We have addition, subtraction, multiplication, division, reflexive, symmetric, transitive, and substitution property of equality. Let's start from the very first one, addition property of equality. If A is equal to B, then A plus C is equal to B plus C. Okay. For subtraction property of equality, if A is equal to B, then A minus C is also equal to B minus C, since A and B are just equal. For multiplication property of equality, if A is equal to B, then AC is just also equal to BC. Division property of equality, if A is equal to B and C is not equal to 0, because if C will be equal to 0, it will become indeterminate. Then A over C is equal to B over C. For reflexive, A is just equal to A. For symmetric property of equality, if A is equal to B, then B is just equal to A. Transitive property of equality, if A is equal to B, then B is equal to C, then A is also equal to C. And lastly, for substitution property of equality, if A is equal to B, then B can be substituted for any A in any expression. So most likely, ginagamit natin yung substitution property if we're going to find the values of unknowns. Okay. Examples of deductive reasoning. Solve for the values of x using and supply the properties shown in the equation. So we have there 2x plus 6 is equal to 8. So first and foremost, we just have to transpose 6 to the other side. So from the first one, we have the given. So dito, no? Tingnan muna natin tong part na to. We have the given, and we're going to transpose 6 to the other side using subtraction property of equality. Okay, what we subtract here will also be subtracted on the other side. Okay, so since we want to eliminate this part. Okay, then we have here the closure property. Okay, after the closure property, we can now get the value of x using division property of equality, and then our final answer will be equal to the closure property also. Okay, now let's try to solve this problem. Okay, we have there 4 times 3x minus 8 plus 5 is equal to x minus 5. Okay, we have here the given. Okay, the first thing that we have to do is to distribute these multiplication sign over the groupings. So we follow multiplication property of equality. Then 12x, it will give us 12x minus 32 plus 5 is equal to x minus 5. For us to be able to get rid of the number x here on this side, we have to apply subtraction property of equality. So if you can see, so this will now be eliminated. Okay, and we can now have this. Okay, 12x minus x. It will give us 11x minus 27 is also equal to negative 5. Okay, this one will be our closure property. Okay, 11x minus 27 plus 27, we are now going to use our addition property of equality or the APE. For this part, since we want to eliminate negative 27 on the left side to brought that on the other side. Okay. Then the next part, this is also a closure property of equality. Then what we're going to do next is, since we have both values of the variable on the left side and a constant on the right side, we can now solve for the value of x using division property of equality. And lastly, if we're going to perform the indicated operation, it will give us the value of x. So this is the closure property of equality. Okay, now let's proceed to the next topic, which is all about the logic puzzle. Logic puzzles can be solved using deductive reasoning and a chart that enables us to display the given information in a visual manner. Okay, just like this example, Anne, Enya, Alvin, and Jenny have different favorite colors: red, blue, green, and orange. No person's name contains the same number of letters as his or her favorite color. Alvin and the boy who likes blue live in different parts of the town. Red is the favorite color of one of the girls. What is each person's favorite color? So for us to be able to determine the color, it is easy if we can draw a diagram or if we can draw a chart about this problem. So meron naman tayong mga context clues. First, meron silang different colors, different favorite color. Okay, the second one is no person's name contains the same number of letters as his or her favorite color. Let us use that one as one of our context clues. It means that if there is their favorite color is not equal to the number of letters of their name, it only means that red is not the favorite color of Anne, because red has 3 letters and Anne's name has also 3 letters. Okay, that's the same with Enya. So, hindi niya na favorite yung blue kasi 4 letters lang yun. For Alvin and for Johnny, the orange. Okay, this will be our first context clue. For the second context clue, Okay, Alvin and the boy who likes blue live in the different parts of the town. So, sino nga ba yung boy? Okay, dalawa lang naman yung girl dito at dalawa yung boy. The first boy is Alvin and the second boy is Johnny. So, it is referring to the other boy who likes blue. So, if that is not Alvin, then that is Johnny. So it means that Johnny was the one or is the person who likes blue. So we can just cross this out since hindi niya na nila favorite yung blue because that was for Johnny. Okay. For the third one, red is the favorite color of one of the girls. So meron na tayong mapping diagrams dito. Red is the favorite color of one of the girls. So if dalawa lang naman yung girl natin, no? If Anne is or if red is not the favorite color of Anne, then that was for Enya. No? And then we can just cross this out. Ano pa ba? So we can just also since we have three cross here, it only means that this was the favorite of Anne. And what more? So, alin pa ba yung wala, no? Alvin is for orange. So, we can say that this completes our table. Okay, this is how we're going to solve problems in deductive reasoning following our context clues. To sum it all up, let us find the differences between inductive and deductive reasoning. Okay, for inductive, we reach out conclusions based on the series of observation, while in deductive, reaching conclusion based on previously known facts. Okay. Also, for inductive, conjecture may or may not be valid or certain because these are just based on observations. For deductive, conjectures are correct and valid or certain. Okay, these are the differences between inductive and deductive reasoning. So examples, determine whether the argument is an example of inductive reasoning or deductive reasoning. Emma enjoyed reading the novel Finders Keepers by Stephen King, so she will enjoy reading his next novel. Is this an example of inductive or deductive reasoning? So as you can see there, it is not referring to the novels of Stephen King, but the particular novel Finders Keepers. So by observation, he just find out that this is an inductive reasoning. So bakit po? Because it is not particular to the novel, but to the works of Stephen King. The next example is all pentagons have exactly 5 sides. Figure A is a pentagon, therefore figure A has exactly 5 sides. So we all know that all pentagons, this is a fact. So if figure A is a pentagon, so we all know that pentagon has 5 sides, therefore figure A has exactly 5 sides. This one is done using deductive reasoning since we have facts. These are not just based on observations, these are based on facts. Okay. Next, every English setter likes to hunt. Duke is an English setter, so Duke likes to hunt. So this is an example also of deductive reasoning since we have facts there that every English setter likes to. Okay, we have two forms of deductive reasoning. The first one is using hypothetical syllogism and categorical syllogism. Let's start first with hypothetical syllogism. It is a type of deductive reasoning consisting of a conditional major premise and an unconditional minor premise and an unconditional conclusion. Okay, the first type of hypothetical syllogism is what we refer to as modus ponens. Okay, this is also part of our tautologies. It is a hypothetical syllogism with the form if P then Q and P therefore Q. So we can see these symbols P implied Q, that is if P then Q, P therefore Q. So we can see these symbols in our modus ponens. So paano daw ba to? If P then Q, P happens, then conclusion will happen. If our hypothesis happened, then the conclusion will likely to happen, since that will be our basis for our propositional logics. Okay, let us have examples. For example, if Alison vacations in Paris, she will have to win a scholarship. Alison is vacationing in Paris, therefore Alison won the scholarship. So we have there P implied Q. Alison is vacationing in Paris. It means that P happened. Therefore, Q happened, or Q will likely to happen. So this is what we call modus ponens. On the other hand, there is another type of hypothetical syllogism, which is modus tollens. This is a little bit different with modus ponens based on the form. Now, it is a hypothetical syllogism with the form if P then Q and negation Q, or the conclusion didn't happen. So it means that the premise or the hypothesis didn't happen also. So we have there P implied Q. Q didn't happen. Therefore, P didn't happen. So hindi kasi nangyari yung conclusion. It is most likely that the hypothesis didn't happen as well. Let's have some example of modus tollens. If the traffic is bad, Jim will be late to the movie. This will be P implied Q. Okay, so let's see the other statement. Jim was not late. It means that we have here negation Q. It is most likely that Jim was not struck in the traffic. So therefore, negation P. Okay, this was one of the examples or one of the types of our hypothetical syllogism, which is modus tollens. Okay, let us differentiate modus tollens from modus ponens. When we say modus ponens, okay, this is all about P implied Q. P happened, therefore Q. Okay, so this is modus ponens. On the other hand, we have P implied Q. We have our conditions here. Q didn't happen, therefore our hypothesis didn't happen. Okay, this is what we refer to as modus tollens. Okay. Based on the structure, makikita natin kung anong type of syllogism yung ginamit. Now, we have categorical syllogism. So, ano naman yung categorical syllogism? It is a form of deductive reasoning wherein a categorical conclusion is based on two categorical premises. So, there are four types of propositions that are used in the syllogisms. We have the positive universal, negative universal, positive existential, and negative existential. So, for positive universal, we use all R. For negative universal, we use non-R. For positive existential, we use some R, and for negative existential, some are not. Okay, so these may be our context clues for categorical syllogism. We categorize our conclusion based on the propositions that we use. So there are three types of propositions will be used to create an argument in the following standard form as defined by One, we have the major premise or the universal quantifier. The second one was the minor premise or the existential quantifier. And the third one will be our conclusion. Okay, let's have an example for us to understand this further. Okay, it is denoted by all P are Q, R is P, therefore R is Q. Okay, so P R Q, R is P, therefore R is Q. This will be our form to follow in the creation of categorical syllogism. So pwede din naman gumamit tayo ng ibang ibang form, pwedeng sum or none P R Q, or sum of P R Q, or sum of P are not Q. So we can use other types of categorical syllogisms. Now, for example, if all fish are sea creatures, every shark is a fish, therefore every shark is a sea creature. Okay, we have here all P are Q. So R is P. So therefore R is Q. Okay, this is an example of categorical syllogism. Now, we're going to end with these examples. Determine whether the following statement is valid and justify your answer. So, all College of Arts and Sciences faculty members have a master's degree. Okay, that is one of the qualifications if you want to teach in the College of Arts and Sciences. Okay, Mr. Lozada is a College of Arts and Science professor, therefore he has a master's degree. Okay, this one is valid since we have met the first major premise. Okay, the second one, all even numbers are divisible by 2. We all know that by conventions and by facts that all numbers or all even numbers are divisible by 2. The number 506 is even, therefore it is divisible by 2. This one is also valid since we follow a certain facts. Lastly, number 3, reflex angles are angles that are more than 180 degrees. So that is also a fact. The angle is 235 degrees, therefore it is a reflex angle. So that is also correct since 235 degrees is greater than 180 degrees. Okay, so these 3 statements are valid under deductive reasoning.